Hi, Algebra 1. I hope you all had an awesome Thanksgiving and that you enjoyed your extended snow day break. I am away at a conference today, so I am obviously not there. I will be back tomorrow, though, so don't worry. But I did want to give you a little bit of a head start, especially since we missed Monday, Tuesday of what our next unit is. So in front of you, you should have a notes paper where the very first slide should look like this. Yours to save paper, I printed more than one sort of slide on a sheet of paper. So we'll just ask that you go along, you follow along with the video, and that you take some notes here as we go through. Remember, you can pause, you can stop, you can rewind at any point. So if you feel like I'm going too quick, remember that you can pause me. So let's get started. We are going to start chatting about inequalities. So before we really dive into inequalities, I just wanted to see some similarities and some differences between inequalities and equations. And I know that this is an equation because there's an equal sign here, and this is an inequality because there's an inequality sign there. So when I plug in -1, so this, I have some x values, and I want to know, is this a solution to the equation? So here I have 2 times -1 plus 3 is equal to 5. Is that true? Is -2 plus 3 equal to 5? And no, that's not true. So this is not a solution. How about 2 times 0 plus 3 is equal to 5? That's equal to 3, so that is not a solution. 2 times 1 plus 3, that is equal to 5. So here we have a nice winner here. 2 times 2 plus 3 is equal to 5. That is not equal to 5. 4 plus 3 is equal to 7. And last, so that's not equal. And 2 times 8.5 plus 3 is certainly not equal to 5. So also not a solution to the equation. So let's think about what happens when we're talking about inequalities. So 2 times -1 plus 3, is that greater than 5? Is 2 times -1, so that is going to give me -2 plus 3 greater than 5, which gives me 1 is greater than 5, and this is not true. What about 2 times 0 plus 3 is greater than 5? Is 3 greater than 5? It is not, so also not true. 2 times 1 plus 3, is that greater than 5? Well, is 5 greater than 5? No, 5 is equal to 5, so also not a solution to the inequality. 2 times 2 plus 3 is greater than 5. That's going to give me 4 plus 3, which is 7, and 7 is greater than 5. So here we have a nice winner. And let's go back to my pencil. And 2 times 8.5 plus 3, that will certainly be also greater than 5. So it looks like here we have 2 winners. So we have 2 sort of solutions here to this inequality. There are 2 times where these numbers that I plug in here are greater than 5 when I multiply them by 2 and add 3 to them. So let's just go through and answer some of these questions. How many solutions to the equation and why? So I just want you to think about that and jot down maybe some reasons why there's only one solution to the equation and why that would be. And then I want you to think about which numbers in the table are solutions to 2x plus 3 is greater than 5. And are these the only solutions that exist? What if I continued my table and I plugged in -5 or I plugged in 86? Are these the only solutions that exist? Then, it looks like we had a double slide there. So now I just want to now that we've talked about a little bit and you've thought about how inequalities can have more than one solution, and oftentimes they do have more than one solution. They have a range of solutions here. So coming back up to this, and we'll talk more about this in class tomorrow, but just to give you a little bit of a preview, we would say that the solution to this, it looks like it's numbers that are bigger. It looks like this was sort of our cutoff point here. This was our cutoff point here. It was between 1 and 2. So as we go further with these, we'll talk a little bit about how to write our solutions to these problems. So sorry if this scrolling is making you dizzy. So working algebraically with inequalities. So taking a look, is 4 less than 6? Is this true? So yes, this is true. 4 is less than 6. So I just want to kind of experiment here. Is it still true if I add 3 to both sides? Is this still true if I add 3 to both sides? And it is. 4 plus 3 is 7, and 6 plus 3 is 9, and 7 is less than 9. So now I want to talk about what is the solution set for this inequality, and I want to graph it. So x values that are less than 5. So all of the values that are less than 5. What I want to do is I want to put an open circle here where my 5 is, and we'll talk a little bit more about open circles and closed circles as we go on. And all of my x values that are less than 5 is where I want to shade here. So this is the solution set graphed, and I could keep going here, graphed, where my x values are less than 5. So any number that's over here that I could plug in for this x would make this inequality true. If I plugged in anything that was up here, it would make it false. For example, 7 is not less than 5. So that's a little bit about graphing these inequalities. So here, what's the solution set for this inequality? Well, we just talked a little bit about up here how I can add the same number to both sides and my inequality rules sort of still apply. So here, I want to add 5 to both sides. So plus 5, I end up getting that x is less than or equal to 8. So this is the solution set for this inequality. And I can go ahead and graph this, and I can put a closed circle on 8, and I can go ahead and shade all of my x values that are less than or equal to 8. So that closed circle is because we have values that are equal to 8. So less than or equal will be all of these values down here, x values that are less than or equal to 8. So by adding the same number to both sides of this inequality, I was able to isolate my x value, and I figured out what the solution set was for this inequality. So let's move forward here, but before we do move forward, I just want to talk with you a little bit about some other notation that we could use to talk about the solution set, and it's called set builder notation. And I don't think you have a slide for this. So set builder notation, since my solution set is x values that are less than or equal to 8, we can say that the solution is x values such that, so this line right here means such that, so x values such that x is less than or equal to 8. And we'll go ahead and put all of that in curly brackets. So that's how we write the solution set for these inequalities. So we can state the solution set, but we can also graph the solution set. So let's take a look at another one. So here, is this true? Is 4 less than 6? Yes, it is. Yes. This is true. Is it still true if I subtract 3 from both sides? So 4 minus 3 is 1. 6 minus 3 is 3. Is 1 less than 3? Yes. Still true. So here, what's the solution set for this inequality? So I can just subtract the same number from both sides. I can subtract 4 from both sides and isolate my x here. So I end up getting that x is greater than or equal to 5. So my solution set is x values such that x is greater than or equal to 5, all in curly brackets. So I can come over here. I have a closed circle because I'm allowed to have values that are equal to 5. And I just want to go ahead and shade all of the values that are greater than or equal to 5. So this would be the graph of this solution set. All right. So I am not going to get into the multiplication. So I'm actually going to scroll all the way down and end up popping up a blank. So we're going to skip over some of this from now, and we'll pick this back up sort of a little bit later. And I don't know if this is on what you have right now. But I just want to ignore these problems for now. So here, why don't we go ahead and do this? Let's put some stickies. So let's go ahead and I'll write all over this. So I just want to do a few practice problems with you that are on your homework that you're about to get. So v minus 9 is less than or equal to negative 13. So I want you to solve this. So solve each inequality and graph its solution. So what I can do is I can go ahead and add 9 to both sides, and I get that v is greater than or equal to negative 4, and you have your own little number line, but I'll make my own little number line right here. And here is negative 4. Values that are greater than or equal to 4 will be all of these values that are in this direction over here. We'll do one more together. I have x minus 7 is greater than or equal to negative 6. I'll sketch in my number line, but before I do, I'll add 7 to both sides, and I end up, getting that x is greater than or equal to 1. So here's 0, here's 1. I have a closed circle, all of my values that are greater than or equal to 1. And going back to our set builder notation, for this first problem over here, my solution is v values such that v is greater than or equal to negative 4, all in my curly brackets. And my solution set here is x values such that x is greater than or equal to 1, again, all in my curly brackets. So you have some inequalities practice. It is about 16 questions for you to just go through and solve. And we will check these out tomorrow in class. And tomorrow we'll really formalize a lot of these notes. And we'll go back to some of the things that we've skipped up here. So good luck with your problems. And I will see you all tomorrow. Bye, guys.